Okay, so we are finding intercepts. So just real quick, if I take a look at any graph, right, doesn't even really matter what it is. Oh, I don't know. Let's say I had that line, right? So this line crosses the x and y axis once in each location. In order for me to find, so here would be its y-intercept, right? What is true about x at that spot? The x value is 0, right? So if I'm given an equation and I want to find its y-intercept without having the graph done out, all I have to do is plug in 0 for x, right? Because it doesn't matter where this line crosses the y-axis, wherever it happens, I know the value of x has to be 0. So likewise, so y-intercept, plug in 0 for x, because that's what it will be. So likewise here, to find my x-intercept, I have no idea what that x-intercept is, but I do know what y is. Y must be 0, right? Plug in 0 for y. Okay, so if we take a look at the examples on the bottom of this note sheet that you have, right? These are so convenient, these sheets here. So let's take a look at these 4 examples and see if we can just find those x-intercepts together. Okay, so the first one is just y equals 2x plus 7. All right, doesn't matter which one you find first. Say I wanted to find the y-intercept, but you guys are smart. You already know what the y-intercept is. It's 7, right? Because this equation just so happens to be in slope-intercept form, and we know that b is the y-intercept. But even if I didn't know that, if I plugged in 0 for x, I would get out a 7 for y. Okay? So that's going to be at 0, 7, and my x-intercept, in order to find that x-intercept, remember you plug in 0 for y. So I'd have 0 equals 2x plus 7, and then I would just have to solve for x. So negative 7 halves, right? So that x-intercept would occur at the point negative 7 halves, comma 0. So far so good? All right, let's try the next one. Has an absolute value in it. So that one looks like this. Y equals absolute value of x plus 1 minus 3. Okay. So if I wanted to find the y-intercept, let's plug in 0 for x and see what comes out. So that's just 1. Absolute value of 1 is 1, and 1 minus 3 is negative 2. So I get that y-intercept would occur at 0, negative 2. Agreed? Yeah? Did you guys try these? Did you get the same thing? So let's try the x-intercept. Plug in 0 for y. All right, so now we just have to solve this for x. So let's start by adding that 3 to the other side. And then what do you do again? Refresh my memory. When I have an absolute value equation, how do I solve from here? Say it again. Right, I have to rewrite it twice. Set it equal to positive 3 and to negative 3. So I'll have x plus 1 equals 3 and x plus 1 equals negative 3. And then solve each one. So I get 2 and I get negative 4. So what does that mean about this graph? It must have 2 x-intercepts, so it crosses the x-axis twice. What shape is this graph? Do you remember? A V shape, so it makes sense that it's going to hit that x-axis twice. Okay, so my x-intercepts are at 2, 0 and at negative 4, 0. Perfect. Okay, let's try the next one's a quadratic. Let's see if I can fit it in here. X minus 3 squared minus 4. Okay, x-intercept, let's try it. Oh, I was doing y's first. Okay, y-intercept then. So let's plug in a 0 for x. So let's see, that's a negative 3 squared is 9 minus 4 is 5. Okay, easy enough. So that's at 0, 5. And then my x-intercepts, plug in 0 for y. Let's add the 4 to the other side, then maybe I could take a square root. Right? Square root both sides. Don't forget plus and minus. So now I just add 3 to the other side, so that's going to get me out 3 plus 2 is 5, and 3 minus 2 is 1. So my two x-intercepts this time are 5, 0, and 1, 0. What do we think? Let's see if we can real quick get this last one in before the bell rings. I would like you to do that other sheet if you could finish that for homework. But let's see if we can get there. So, y-intercept. Plug in 0 for x. Well, that's easy enough. That's just 0, right? Okay, so great. 0, 0. But that x-intercept. Here's what you can't do right here. You can't take this equation and divide both sides by x. Because x could be 0, and then you're breaking the universe. What I can do is I can square both sides to get rid of that square root, right? So I can square u, and I can square u. Just be careful when you do that. This side turns into x squared, and then I'm still multiplying it by that. So you need to make sure that you're going to distribute that x squared. Does that make sense? So you've got 4x squared minus x to the 4th. Now I can factor that bad boy. Let's take out I can take out x squared, and I'm left with 4 minus x squared. But isn't that the difference of two perfect squares? So can't you factor that again? So if I factor this completely, I get 2 minus x, 2 plus x. And now that I have it fully factored, I can set each factor equal to 0. That means this thing is going to cross the x-axis at 0, positive 2, and negative 2. Do you see that? Okay. So I got 0, 2, and negative 2 as my answers, which means all of my x-intercepts are at 0, 0, 2, 0, and negative 2, 0. All right. So, thanks for your attention, sticking it out, and we made it before